Good morning, super friends, on this very fine day of Bathurst. Not that I'm particularly excited about the race, but it's kind of a cool event. And right now it is playing on the TV upstairs, although obviously the main race hasn't started. It's all just the talking heads stuff, hearing all of the deep wisdom from the drivers. Okay, I'm not going to get too cynical. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Okay. Hang on. Where am I? Am I here? I hope I'm here. YouTube thinks I'm here. Oh, I've got picture-in-picture happening. Hang on. Can I... No, I can't. Oh, if I go that way... no, if I touch there with that finger, and where is it? I can almost do it. I can't quite contort that way. All right, where is picture in picture? If I switch to that view, no, it comes back on again. What if I switch to that view? It goes away. Switch to that. This is kind of funny because what it's doing is it's turning on picture in picture when it's meant to be off, and it's turning it off when it's meant to be on. What if I go to the overhead camera? Then it goes away. Odd. All right, I'm going to turn it off manually. Okay. Do cynical. Okay, Ray says I should do cynical. Yes. Where are we? Okay, Gavin was first. First post. Good morning to Gavin, Austin, Peter, Henrik, Stephen, Dodgy, David, Chip is here. So Chip and Imi are nearby. They're not physically here at the factory. They're going to be turning up pretty much at the end of the stream, I think. And here for the barbecue. Where are we? Okay. Good morning to Keith, Stephen, Russell, David, Delane is here, Amanda, I think I said hello to Austin, Mad Techie, Ray, Luminator, Tradie, Justin C, Matt is here. Good morning. Are you coming to the barbecue, Matt? Maybe not. I don't know. I hope you do. Now, what are we doing today? Okay, so all right, so the quick final sort of wrap up thing on the OpenKO board is that I did end up sending it to production. I did a huge PCB order during the week because I have a client that wanted a large quantity of boards ordered. So my PCB order ended up being 13 kilos of boards, according to the shipping estimate. So it's a lot of boards. And I ended up ordering boards for Matt as well. Oh, cool, Matt, you will be there. Awesome. Oh, Casio is in the chat. And so I ended up ordering some boards for Matt and also for a couple of other clients. And I put the OpenKO boards into the same order. And I expect that they will probably arrive on about this coming Friday, maybe, give or take. A few of the boards, including the OpenKO, were 4-layer boards, which adds an extra day or two to production. And then maybe even next live stream we can assemble an OpenKO, which would be cool. And then maybe we can run the OpenKO on the KO and use that to assemble more OpenKOs. Which is a little bit like Sion used to use his Reflow master boards to assemble Reflow master boards. Yeah, board inception, order history. Sorry, what I'm doing right now is just logging into JLC, but I'm doing it off screen because I've got a whole lot of customer boards listed in here because I want to see the production status on those boards. Where are we? File manager, here we go. Okay, so the OpenKO is currently at, solder mask is done. It's currently at silk screen, and then it needs hassle and then inspection, and that's it. it is almost ready to go. There's another board that is a little bit behind it that'll probably hold it up. Where are we? There's another board that is still at the optical inspection stage before solder mask. That's not that far behind. Yeah, so I reckon all those boards will be finished in the next day and then DHL shipping. So yeah, I should have them sometime late-ish in the week. That means an assembly session next live stream. In fact, what would be cool would be, instead of doing it under the microscope, well, some of the parts will have to go on under the microscope, just, you know, the hand-placed parts that aren't in the machine. But, okay, this is what I want to do. Next live stream, I want to run one of the KOs and get it to assemble the open KO board. And that would be pretty cool. So I'll get a camera. I already have a camera set up actually physically inside the machine. There are a few things we can do. What I can do is capture the video coming off the controller. In fact, I can kind of do that right now. If I go to, what am I going to do? Okay, I'm going to connect. This has been a whole lot of just blah so far. Where are we? Go. Connect to server. Okay, you can't see this just yet, but I will bring it up for your viewing pleasure in a moment. So what we can do, unable to resolve. What is going on with my network this morning? That machine is running, I'm pretty sure. I was just trying to connect to the controller that's running the KO. I don't know. Anyway. It doesn't really matter. All I was trying to do was bring up the interface so that I can show streaming the video from the capture, like from the optical alignment cameras inside the KO, and I can pass that through to the stream. So we can actually, oh, Henrik said, what was your order final price? If it's okay to ask, let me guess, 1,000. You're not that far off. Including shipping, it was about $800. And about half of that was shipping. Half? Not quite half was shipping, but shipping was like $360 or some crazy thing like that. Peter said, yes, it's always DNS. It is always DNS. I have a feeling that what happened, yeah, I suspect that it's all going to come back. Sorry, I'm glancing around at the rack, which is just through the window there. The thing is, just before the live stream, I actually turned off the office lights, and I think something screwed up, because what happened is that it also turned off the lights in the rack. So I saw that some stuff in the rack powered down, and I think it powered down the I'm just trying to see if it's powered up. I think it powered down the access point, because the access point is running off PoE through the rack. So I think part of my network basically got turned off by accident, and it's all just, oh yeah, get the Jeff Gilling DNS t-shirt. Yeah, it's always DNS. Now, yeah, so part of my network is, or has been, rebooting. I don't know. Oh, Johan is here. Someone else just arrived as well. Dave Paul Jones has arrived. Excellent. Gerald is here too. Okay. Yeah. Okay. So Henrik was asking. Yeah, okay, I misunderstood. What was the final price? Okay, so I thought that your question was about my huge order, huge customer order. But no, it was just for, what was the price for the open KO boards? I think it was in the order of $20, you know, give or take. And I'm pretty sure I only ordered a 5-pack. So it was a 5-pack of boards, but with, what color did I go for? I can't remember. Let's see what it says in the order. I think I might have selected blue for that one, and that doubled the price. Yeah. Oh yeah, here we go. It was Australian dollars, $18.37 for 5 pieces, 4 layer with blue. If I hadn't selected blue, it would have been about $10, but it nearly doubles when you go for a non-standard color. All right, so the point, where are we? Oh, Don S is here as well. Okay. Sorry, I am so distracted today. My phone just buzzed. This is what happens when it's barbecue day, because I'm, yeah, I've got messages to people about whether they're coming or not, and people replying and asking questions about what they should bring and all of that sort of thing. So on barbecue days, my notifications are busier than usual. And because it's right after the live stream, it's best if I don't disable them. So, what are we doing today? Oh, Keith, cool, you'll be here as well. That's good. Now, let's see, if I switch to this view, looks like it's working again. All right, so what I wanted to do was refocus on, libraries will be out of date because I'm managing these libraries now through Fusion and doing updates there. So when I open Eagle, which doesn't happen very often these days, it finds out-of-date libraries. Yes. Oh, Stephen says, I put together a PoE-powered ESP32 based internet radio streamer. That's pretty cool. Oh, also, when I was reading names earlier saying good morning to everybody, I wasn't actually reading any of the messages. And I'm just skimming through, I saw a message, I think it might have been Austin, saying something about posting a schematic for PoE related stuff. Just quickly scrolling down. Okay, so Austin said, in case it helps, I sent the PoE schematic to you. All right, which means I should probably open Discord, but I will start that update. I will take that off view because I have no idea what is going to come up on screen when I open Discord. Okay, is Discord going to do its downloading update 1 of 5 thing? No, it's not. All right, let's go back to there. All right, so I haven't started converting to KiCad. Ooh, PoE auto switching. Okay. Also has non-bridge resistors used to ensure the proper on-off settings. Right, nice. Okay, so Austin has sent me a schematic for the auto power source selection. I'm just going to click open in browser because, so I just wanted to confirm before I show this publicly. Austin, is it okay to show this? Oh, there's a Henrik from Denmark as well. So we've got 2 Henriks in the chat. That's cool. So where are we? Is it in GitHub? I don't know. All right. So anyway, if Austin confirms that it is okay to show this. Share away, board files are on GitHub and your bench. Okay, and my bench. Right, so this is the schematic that Austin has sent. And so what we have here, it's funny, when I hear those words, my automatic follow-on is, what we have here is a failure to communicate, which is appropriate when we're talking about power over Ethernet. So this is the Ethernet jack, or the RJ45, or if you call it an Ethernet connector, people say, no, it's an RJ45 connector. And if you say it's an RJ45 connector, people say, no, it's an 8P8C modular connector. So I think technically this is an 8P8C modular connector. We've got the VA and VB pairs coming off here for the power over Ethernet. So this is a connector with built-in magnetics, and I'm pretty sure it's got the built-in bridge rectifiers as well coming off. So it's got the diodes required to extract the PoE, and then those two pairs go into this. So we've got VA1, VA2, and then down here VB1, VB2, and this is coming through this. So it looks like this is the auto switching part of the circuit. So what else do we have? So over here we've got a MAX 1506, which I'm not actually familiar with that part number. That's interesting. Maybe this is a regulator I haven't seen before. And the yeah, so it's pretty clearly a switch mode regulator. You can tell, it's easy to see. We've got a big inductor on the output side. We've got a feedback reference voltage pin on here, V-in, mode control of some kind, VCC with a cap to ground. Oh, Austin says, blast from the past, the switcher can be seen here, and he's put a link to a YouTube video in the chat, which is probably one of his videos. So we've got a bridge rectifier here. Oh, interesting. So it's an external bridge rectifier. Maybe that particular connector does not have the built-in rectifier. So yeah, I probably wouldn't, because it's got VA and VB. If it had just like a positive output and a negative output, that's when they've got the built-in rectifiers. So this one probably doesn't. So we've got a bridge rectifier here coming from VB1, VB2, and that's going into, so the output of that rectifier is going into this switch mode regulator, and the output of that regulator is going to a few places. So that's the 3.3 volt rail. We've got the relay here, which is being controlled by it as well. So when this is receiving power, it powers up and it fires this relay, and then the normally closed contacts would be connected. Sorry, the normally open contacts would be connected when that relay fires. And here we've got control over the relay ground. So we've got positive going to that part of the relay. So it's a low side switch going through this MOSFET, it looks like. And then we've got a snubber diode and an indicator to show the status. And this thing, the TPS 3700, what is this? So we've got in A plus, in B plus, out A, out B. Oh, excuse me. Ground and power. Austin says the rectifier is the same as on the PoE module. Was used just to add some protection, but the board sent to me doesn't have it because I used the wrong resistor values for it to work. Oh, okay. Alright, so TPS 3700. I have no idea what that is. What is a TPS 3700? Let's have a look. TPS 3700. I've been to that data sheet before, so this is just another demonstration of the fact that the computer has better memory than me. Window voltage detector with internal reference for over and under voltage monitoring. Aha, right. Okay, so that is what is doing control of the relay. That's right, my memory is slowly coming back to me. This is the clever thing that Austin did to detect the different PoE modes or types. So that voltage window detector is being used to conditionally control the relay depending on which PoE mode it is in. So if the voltage is within a certain range, then it fires this MOSFET, which turns on the relay and changes the PoE mode. That is very clever. Yeah, nice work, Austin. This is very cool. Oh, Dodgy says throttle position sensor. Yeah, TPS. In an automotive context, that is normally what TPS means. No, in this case, it is well, TPS is probably the manufacturer of the part. T for Texas. I don't know what TPS stands for in this context. Yeah, so, and there's another regulator, the LM2596. So we're getting 5 volts coming out of this, and this is giving us, looks like 3.3 volts. So we've got a 5 volt and a 3.3 volt regulator on there. All right. Well, Austin, that is pretty clever and interesting. Logo 1, Creations Logo Medium. Nice work. Yeah. Okay. So what I was wanting to do was refresh my memory, and as we've all seen, my memory is bad. I'm going to refresh my memory on where we were at with the, I'm just moving it down onto the other monitor so that I don't lose it. What was I doing? That's right, closing that, and we got this. I don't even remember if this was the most recent. I don't know where we left this. So other people are going to have to yell at me, tell me what it should be. Now this regulator, if I was doing this now, I would probably replace this, or maybe, I don't know what the current requirements are. Maybe a 2596 is still the appropriate solution to this. But I would probably use something like an LM38020 in this context now instead. It's a lot cheaper than the LM2576 and smaller. The 2576 is a nice regulator, but I'm kind of very enamored of the LM380 series regulators at the moment, so that's what I've been messing around with. Looks like the most recent, says Austin's. Yes. Dodgy said, is it my imagination or do you seem calmer today, John? Maybe. Maybe. Yeah, last Sunday, what was going on last Sunday? Last Sunday, I was mentally not in a very happy place at all. I was not in good shape. I was much better by the end of the stream. I was feeling so much better after talking to you all. But when I started it, I was, yeah, I was not good, not good. Today, I'm kind of excited because we got the barbecue. And I'm looking forward to having a bit of a social time after the live stream. An in-person social time in addition to the online. Okay, so Austin says, we spent a lot of time talking about the LM2596 as it would meet the needs, but you might be able to go a little bit lower. Minimum, I'd say 2 amp. Yeah, so 2 amps is the, because this comes down to the power requirements of the Raspberry Pi. Now, part of the reason, there are a couple of things that made me think about this project again and want to resurrect it. A few factors. One is that I like doing these projects on streams. It's a way of keeping me accountable and moving ahead on them. Just for the projects that otherwise would just sort of sit in the background and I'd never get around to. Oh yeah, TPS is tire pressure sensor. That is another automotive acronym for it. But yeah, most commonly in an automotive context, I've seen it as throttle position sensor. But yes, tire pressure sensor is also valid. So, having got the OpenKO board sent off to production, I was starting to think about, okay, what other projects can I work on the stream? And there is Amanda's presence sensor project as well, of course. But that's yeah, I'm kind of slightly peripheral on that one. It's not really my project. I'm just an enthusiastic bystander, and hoping that that goes somewhere, that maybe I'll get directly involved in whatever design needs to be done, but there are other people that are interested in that one as well. So I thought that what I would do is resurrect this. The other thing is talking to, I don't know if it's okay to reveal this, so I'm not going to say anything specific about it. But during the week, so I'm going to talk about this in a circumspect way. I have a client who has a need for Wi-Fi with access points that can be controlled and isolated from the rest of a network. So say you've got an existing facility somewhere, you know, like a building with all of its existing infrastructure. It's got wired Ethernet and Wi-Fi, etc. And you want to introduce another network within it which has a number of devices, and you want this to be totally isolated from the rest of the network. So it's the sort of thing where in a corporate environment you would put in VLANs, you'd run something like Unify access points with multiple SSIDs and VLANs so that you could isolate something. But it's not quite that scenario, it doesn't quite fit that, and for reasons I won't go into. And so the solution that they're currently looking at is to install Unify access points into many, many locations and have them all centrally managed. But the thing is that the rest of the network that it's installed into is not Unify. It could be anything because it's lots of random sites. So the goal is to have some kind of an access point that has good performance in terms of its range. That's a really critical thing for this application. And it needs to be isolated. So the network that it manages needs to be isolated from the rest of the network, and it needs to be centrally managed. So the thing is that if you're using a Unify access point, it is just an access point. It's not a router. It doesn't do anything else. And this access point project, it's most likely that this is not appropriate for my client's requirements. So they, but anyway, so I'm not doing this for commercial reasons. But that conversation with that client, who I won't name, just in case I shouldn't, is what sparked my memory and got me thinking about this. It was after that conversation that I started thinking, yeah, I really want to look at that access point project again, because it's this sort of slightly unusual application that this could be really useful for. Like if you're installing a bunch of IoT devices into a facility and you want to be able to manage those devices and manage the network that is dedicated to them with a number of access points, and be able to do things like control handover between access points. So access point affinity, whether a device is bound tightly to a specific access point or whether it can roam, all of that sort of thing, that can all be controlled if we have direct control over the AP and all of the code that's running on it. Stephen W. said, Unify doesn't care about if the rest of the network is Unify or not. Enable the guest network rules and block certain IP ranges so it's internet only, no local access. Yes. So what that would mean would be setting up... I don't know the answer to this. It's one of those things where I could look it up. But if you don't have any other Unify equipment, like you don't have a Unify router or anything that's handling DHCP, then how do you control DHCP allocations through a Unify access point? because the thing is that the access point itself gets all of its information from the router. It's just an access point. Maybe it can. So if you set up a Unify controller temporarily, so for the commissioning process, put in a Unify access point and have a controller running on your laptop, for example, and then you adopt the access point and configure it, and then you can redirect it to a cloud-based controller so that you can manage it. That gives you management over the access point, but then how do you manage things like, I suppose that would come from the controller. Okay, and Justin C says you can do DHCP relay. Right. Oh, John, mostly Magic Smoke, said, greetings all, just about to get on a plane. Have a smooth flight. Enjoy the in-flight food. Am I strange that I actually like airline food? I don't know why. It's just the novelty of it. It's really frustrating trying to eat like jammed in an airline seat, but it's yeah, I don't know. I think it is just the novelty of it, the little packaged serves and things. Oh, Dave Paul Jones says, I'm doing 100% more work on my projects now that I chopped up my sofa. What? Now I only have an office chair to sit on. 340 plus hours on my new project. Almost done. So the moral of the story is to get rid of that sofa. Right. Why did you chop up your sofa? Was that a moment of madness? An Englishman in Brazil said, I like it as well. Nicer in business class. I wouldn't know. I don't think I've ever traveled business class. All right, so the big refresher. Yeah, so I'm pretty sure that this design is the most recent that I have the physical hardware for. Or is it? So that says, oh, my head is in the way. It says V2.0 down there. Hang on, that one. I'm already forgetting how to use Eagle. I don't know which buttons to click anymore. So now, Raspberry Pi 02W. Okay, now the other factor, the other thing that got me back onto this is this whole thing about availability of Raspberry Pis. Raspberry Pi 02W. I am just doing a quick search on this. So raspberrypi.com. Let's have a look at Core Electronics. There are a couple of places here in Australia to buy it. There's Core Electronics, there's there's Pi Australia. So where's Pi Australia's Pi 02? All good people. Let's bring these up. Okay, so here we've got, yeah, and apologies to everybody outside Australia. I'm just looking at local suppliers here. So Core Electronics, which I made the mistake previously of saying is based in Sydney. It's not in Sydney. Okay, it's in New South Wales. So this is the Pi 02W. This is the one that this other board, that my board was designed around, like this Pi 02W, and 30 bucks, 30 Australian buckaroos or kanga bucks. And I don't see anything about, where are we? Limits, conditions apply, $6 standard postage, which is pretty good. Oh, here we go. Limit of 10 per household. Okay, so there is still a limit, but the limit is 10. I think the limit might have even been 1 for a while, if it was in stock at all. It was just impossible to buy these for ages. But now, I don't need to buy more than 10. That's all right. And Pi Australia, let's see what they've got as well. Raspberry Pi 0WH with soldered headers. 2WH with soldered headers. I don't care about the soldered headers. Okay, so here is the equivalent. Yeah, same thing basically. Do they have any restrictions? Oh, okay, so there's still a limit of 1 per customer through Pi Australia. But, ooh, what's that? Meet the Pi-powered robot that ships other pies. Ah, okay. So that's, ooh, that's kind of cool. Look at this thing going on in the background here. So there's a this little thing that moves side to side, moves forward and pulls a box out of one of these little dispensers, comes over here, and it looks like it opens a door and drops it. Awesome. It's a little shipping robot. Oh, Amanda just tried to use Say, which reminds me, I totally forgot about opening the text chat interface. Let's see if I can find that. Mitchell Superhouse. I'm not sure if it's actually enabled right now. Log in. Go to live. Loading audio. Activate.
Activating the super house.
Yes.
Squirrel.
All right, we now have text feedback. Thank you, Mitchell. So, dodgy, stirring the pot there. Isn't Newcastle an outer suburb of Sydney? Is that the way to make all of the Newcastleians mad at you? Get everybody angry? All right, so the point of all of this is the Raspberry Pis in general, the supply has eased up, and it should now be possible to order something like a Pi 02W. They're no longer totally unobtainium. All right, so check. Pi 2W is available. But there were some issues. Now, this is where my memory is really being stretched. I'm just going to grab my handy little lab notebook and hang on, let's try this. I haven't done anything with the overhead camera for a while. I don't even know where the button is. There it is. Okay. So this is where my notebook was opened from. When was it? 10th? What? Look at the date on this. 10th of the 9th, 2021. I can't remember 5 minutes ago. No wonder I can't remember what's going on with this project. And why is there only one page? There's only one page of notes. So this must have been from this would have been from the previous version of the hardware before we did the version 2 on the live stream. So I've got all of this stuff in here. In fact, this one is the version 1.0 PCB, and this is the one with the PoE regulator lying flat, and it's got the cutout there because it had the rock chip thingy, the Rock Pi S, sitting upside down on there, with Ethernet looping around to a connector there and then coming back out another connector here. All right, so that was the previous one. In fact, here is an assembled one with some patches on it. It's got some bodge wires going down through to there, whatever that was. Okay, so this one I believe was kind of partly working. It was doing something. And I've got some of the Rock Pis and things here. So this one has, why is that, are these just headers plugged in? I don't know what, oh no, I see.
_creations said last IoT app stream was the 18th of December 2022.
Okay, cool. So it was December. That's still a long time ago. 18th of December. All right, so that, and this is the Rock Pi S with an external antenna attached to it. So that goes on here. And I think the issue we had here, well, there are a couple of issues. Oh, that doesn't quite clear. What's going on? Have I plugged it? Oh, I plugged it into the wrong place. Great. It should go there. That's better. And then there's access to the Ethernet port there. Now, we were having throughput issues. I'm pretty sure that was one of the areas where we left it. What's this? This is a mysterious... Oh, it's an enclosure. Okay. So this is an enclosure for the Rock Pi S with microarray. Yeah, that's kind of cool. Now there's also somewhere in here. Okay, I'll put these out of the way just for now, because we also have the prototype that came after that. And that, so I've got some stuff here. This is another Rock Pi with a USB to serial converter attached to it, to one of the headers. And that was for, what was it? Was it for comms or flashing? I think it might have been for initial flashing, like setting up the onboard flash memory. And then we've got enclosures. That one doesn't have anything in it. That one does. So this is probably the most recent prototype. And then I've got a bunch of other things in here. Like, oh, here's Austin's PoE auto switcher. This is the circuit that we were just looking at. Oh, so cool. And what else do we have? Some other boards in there. There's a Volt hat. So this is a Raspberry Pi PoE hat that I did quite a long time ago. Oh, we got some connectors. Other random things in this box of bits. More of the PCBs. So that will be the PCB that I just had on the screen. Slowly getting ourselves sorted. Now, the trick is going to be remembering what the design problems were, like where this was up to at the point where I last looked at it. Because I know that there were things we were going to do. I think we were going to try getting better throughput, because we were getting some really low throughput on this. I have a feeling that we were getting like a few megabits a second, and that was it on the wired Ethernet coming through here. That's on a W55, 5100. I can't remember. I can't even read it without a microscope. What chip was this? Or I could just look at the schematic. It's a 5500. All right. So we've got a W5500. We've got the power supply. We've got PoE on here. This one does not have auto switching. It's got these little PoE bypass headers under here. So I'd have to put jumpers on there if I wanted to use low power PoE. Now that's the problem that Austin's circuit here gets around. So it uses this relay to switch PoE modes. But this is the one, this is the previous version. Austin's now updated this design. Now, what are we going to do? 50 volts, yep. What are we going to do next? I think it comes down to trying to figure out if we're going to stick with something like a Pi Zero W, or go back to a Rock Pi or some other board that has better throughput. And I don't know. Hang on, back to chat. So I can, oh, you had a to-do list somewhere also, says Keith. Yeah, which I think, I have a feeling it may have been in the schematic. I will bring this up in a second. Yes, I had a to-do list, but this particular to-do list in here doesn't tell us all that much. This is from the current design 2.0 with the Pi Zero 2, and down here it's got auto switch PoE destination, which is what Austin then took on solving, and change passive PoE to VA pair instead of VB. So, excuse me, where is that? It'll be in here. So we've got VA and VB, and I have a feeling, my memory says that I screwed up the labeling or something on this, which is why I ended up using the wrong pair. Like I had VA and VB inverted. Now, where do they go? They go to the power supply section. Here we go. So we've got VA and VB coming in here on the input to the DP1435, which is the PoE regulator. And then you can see here, I've got VB coming into the jumpers. And what does it say down here? It says to VA instead of VB. Okay. So that whole power part of it needs a rethink. And when I say rethink, what I actually mean is rely on Austin to have done all the hard work for me and blatantly copy all of his work. David says, to-do list, make a new access point. Yep. Stephen says the SPI LAN was the bottleneck. Using pogo pins or bodge wires to a USB LAN chip would improve performance. Yes, okay. So that is, yes, you're right. That is making my memory come back. The problem was I couldn't get enough throughput to the Ethernet chip, which is why it was only getting a couple of megabits a second when it should have been getting 100. Well, you're never actually going to get 100 megabits a second, but it should have been heading up more into, heading towards the 100, not heading towards like 2 or 3, which is terrible, terrible throughput. Yeah. Austin says PoE switching was a fun challenge. Yeah, it's pretty cool that you got the solution. And the idea of using this voltage window, where is it? No, this one, the TPS 3700, the voltage window detector, that is very cool. Yeah, that's a good solution. Back to here. Yeah, so we need to resolve the issue of how to get good throughput on Ethernet, and which board we can achieve that with is going to then dictate the rest of the design. I think that is a critical thing. If we can't get good throughput on the networking, then nothing else matters, really. So we've got to solve that problem. Trady says, we've done this before, the throughput isn't worth the effort in my humble opinion. Which part of it have you done before, Trady? Are you talking about having used the W5500 for the Ethernet? Yes. Yes, before they were unobtainium, right? Now, Ethernet CS selector. What was going on there? I think this might have just been because I didn't know which one to use, so I allowed for both on the PCB. Mode button, temperature sensor, MAC address ROM. Yeah, the MAC ROM was working, I think. Temperature sensor was working. ID EEPROM. So this is for. Yeah, that was for the Raspberry Pi hat specification. Don has said network of things throughput will be low. That is correct. All right, so Stephen said alternative solution is just to use a Pi 4 for Ethernet and Wi-Fi. Yeah, or a Pi 3. 3B Plus also has that support. But there is a problem with that, which is the form factor of the Ethernet connection. And that is why, so if I come back to, let's go back to the original design. It was that one? No. This one? No. Oh, okay. IoT OP, yep. I must have, yeah, I don't have it here anymore. It'll be in like a previous commit in Git. So I could pull it up if I had to. But the original version, I wonder if I've got one still assembled somewhere. No, I pulled it out of the enclosure. But the original version, this will actually give you a better view of what the problem is. Oh, no, that's not what I want. That's what I want. Of what the challenge is that we're trying to overcome. So this is the Rock Pi S with built-in Ethernet and PoE support. So although we're not actually using it on here, we're tapping PoE off in this link. The problem is the Ethernet connector is here, and we need the Ethernet connector to be somewhere accessible from the edge of the enclosure. So in this case, what you can see here is the Ethernet port there on the PCB connected to the Ethernet controller, which is then connected to the Raspberry Pi. So this form factor all works nicely. There are no random wires around the place. It just mounts in the enclosure and you just plug in Ethernet and away you go. The problem with using something like the Rock Pi S or a Raspberry Pi 4 or 3 is they have the Ethernet on the board like this and we can't get that into a convenient location mechanically. So, well, I suppose it could be done if, let's see, if that was mounted there, it would put that not quite at the right height. It's not far off. All right, I'm just going to try this and I'm going to explain where my brain is going. If it was spaced a little, that would work. I reckon if I put an extra row of plastic spacers in the header, I could make that work. All right, so part of the constraint here is working with this enclosure because this is a cheap off-the-shelf enclosure that I can get, and I want to build the device into this, and then it's got this mounting base as well, so that gets mounted on the ceiling or wherever you want to put it, and then you take your access point and just clip it on. It's like a big smoke detector basically, similar to the way Unify do it, except there's twists instead of slides to clip in. So I'm working with the mechanical constraints of this. Now, I'm not entirely hating the idea of, yeah, that would kind of fit. Oh, but what stakes are on the inside? I'm going to get another enclosure, one that doesn't have anything inside it, and let's see if we can make this fit. Okay, so what I'm thinking, following through this, is, so I'm just, right now, because I'm kind of rebooting this project, I'm just thinking through, how about we rethink it entirely and see if the approach that is being taken is correct. Oh, it doesn't go down low enough, damn. Okay, so in order to bring this Ethernet port down here, what it was just going through my head was we could have a version of the carrier PCB with a cutout in here and headers sticking down. So basically it becomes like an enormous Raspberry Pi hat. So it would sit on top, I'm just going to pull it out of the way, so it would sit on top of this, mount down in there, and then it would bring these headers out into that location. But the issue is, yeah, so the Raspberry Pi would end up there. But just imagine if this hat that's sitting on top of it was not this size, it was actually bigger, like it came out around here into all of this area, and it had the LEDs on it and whatever else. So it was supporting the Raspberry Pi. The problem is the Pi can't go low enough in the enclosure to expose Ethernet through that hole. See, that is as close as we can get, which is unfortunate because the latch on the socket is actually on the correct side. If the Pi is mounted like that, the latch is on the bottom, which is where we need it to be. Now I'm going to pull this PoE hat off temporarily just so I can try a few different things. Okay, so if the Pi was upside down, say it was mounted like that, whoops, like that, then the problem is the latch is on this side and you'd never be able to get the Ethernet cable back out again once you clipped it in. The enclosure would need this part cut away, and even then it's actually not low enough because the height of these USB sockets, the USB sockets are higher than the Ethernet jack, which means it holds it up off the base of the enclosure and it stops the Ethernet jack from going low enough to clear it and come through here. So in the simplest solution to all of this, which would be really nice, would be to just get something like a Pi 3B Plus or a Pi 4 off the shelf and have a carrier board that mounts it in here and takes care of the PoE. So we've got PoE headers. Oh, and the annoying thing is that on the Pi 5 they moved the PoE headers, which really sucks.
Austin's underscore creation said compute module would give you Wi-Fi and Ethernet broken out in a way that easily allows you to add power management and save space.
Yeah, so the compute module. Yes, that's right. So for those of you who couldn't hear that because I was away from the computer, Austin's comment was that the Raspberry Pi compute module would give you Wi-Fi and Ethernet broken out in a way that easily allows you to add power management and save space. Yep, and Studio has said also, what about using a compute module? So where we were at, I think I know where all of that to-do list is. Talking about the compute module reminds me, we had some text notes, including a list of compute modules and alternatives and things. So I'm just going to find this and then bring it up on screen somewhere. Yeah, so Austin has provided a link to the CM4, which I will stick up on screen while I'm continuing to look for this other folder. Okay, so I can find my notes, because there were a whole bunch of compute module equivalents that we looked at as well. There are other companies that make modules that are in this same form factor and have the same connector on them, but have different processors and things. So,
system notification, 1 hour remaining.
1 hour remaining. Notes 1. What's this one? Validation. Why do I have 2 notes? Email from Tony. Oh, okay. Yes, so that's right. Tony did a whole lot of work on the SPI stuff. Right. This was setting MAC address and yeah, cool. Okay. So this text is going to be very small. I'll zoomify this. So these are my notes from some info that Tony, I think it was Tony S, sent me, which was about enabling SPI. So this is all related to the Pi 0 and getting it to work with the external W5500, and then setting the MAC address, and there's a setup script that you can do. So there's a custom overlay that takes care of it all, and then setting the Ethernet MAC address is done like So, yes, that's right. Okay, so that is all very cool. I'm going to close that and bring up my notes, these notes. Okay, and then let's make these ones a bit bigger. So hopefully this is where the to-do list and everything was sorted last time. Aha! This is good to see. Now we can do a recap on where we're up to. Wagon Load says, can you just, yeah, actually I don't know why that didn't do a say. I didn't hear it anyway. So Wagon Loads' comment was, can you just use an Ethernet breakout adapter that puts the port into a workable location? Yeah, that's another option. And that is kind of what I was doing with the, where are we? This version. So what you can't see here, because it's not there anymore, is there was a short Ethernet patch cable that plugs in here. It curved around, went underneath the PCB, and then plugged into this Ethernet port. And that one comes through to here, and that's the external port that you plug into. So it kind of acted like a pass-through and also tapped off the necessary connections for power over Ethernet, and then passed that through to here so that we were effectively taking this Ethernet port and relocating it to here through the cable and then the pass-through. But you could do the same thing without the PCB, perhaps. If there was, now let's go for just say the regular Pi. Imagine the Pi was mounted somewhere in here. Not a whole lot of space actually. Okay, imagine it was mounted about here. What you could do is have a cable that had a plug on this end, looped around, and a socket on the other end, and the socket was somehow mechanically attached in here, so that it was just taking the external connection, passing it through, and taking it onto the board on here. So that sort of arrangement is an option as well. And I do have cables for that specifically, like a panel mount socket with a flying lead and a plug on the other end. So yeah, that's certainly a thing worth considering. There is not a whole lot of space to play around with. Yeah, Austin says restricted to mods, I think. Dodgy says, okay, cars are on the grid, so the time has come to love you and leave you. Have a great day, everyone. See you, Dodgy. Have fun watching Bathurst. So I have Bathurst on the TV upstairs.
Aaron Knox said, John, Chip is asking if you want ice from the shop for the barbecue.
Oh, okay. Sorry, I missed that question, Chip. No, I got one bag of ice this morning, and I've got a plastic tub with a whole heap of drinks in it with the ice on it, and I think the one bag would be enough. It seems to have covered it reasonably well, so I think we're okay. Yeah, Don S says RJ45 pass-through and hot glue. Yeah, that could solve it. Right, now back to here. Oh, but as Austin pointed out, if you're making a custom PCB, then you might as well make it simple all in one. Yeah. Now, back to, I thought there was something else. Okay, so compute module. All right, we will get back to the compute module options in a second. So I can tell I'm not actually going to do anything useful on this stream. This is all just reorientation, figuring out where things were left. And okay, so W5500 Ethernet we got working. So thanks to Tony and others who helped with that custom overlay. GPIO button input. So this was for a button that is exposed on the outside of the enclosure, and it's exposed here. And the idea is that that could be used as something like a pairing button or like a factory reset button or something. It doesn't really matter. All it does is go to a GPIO that we can then detect. So we could be running something like a Python script on the access point that is detecting that button press and then doing whatever we like. Okay, so RGB LED output is okay. Yep, so the LEDs were working. MAC address ROM. Okay, so we didn't actually check that. Pi hat EEPROM didn't check that. Temperature sensor didn't check that. Okay. PoE 12 volt was fail. Change passive PoE pair and check VA VB swap. Yeah, so did this board get patched? I don't know. And the PCB is screwed on. I don't know if I can be bothered taking it off. I have a vague feeling that it might have been patched to make it work. Ah, yes, I can see patch wires through a little hole. So the VA-VB swap I think has been done on this prototype, but it needs to be done in the design as well. Yeah, and this was a comment from Austin. You have VA-VB swapped, currently trying to tap DIY on the center taps, not 4.5 and 7.8. Alright, so then there are just some general notes. Reading GPIO, this is how to read from that
Aaron Knox
button.
said, John, is this not a good excuse to try the new Pi 5 with the new PCIe breakout for performance?
Ooh, PCIe, that sounds like quite a challenge. And how much is a Pi 5? It just feels like Raspberry Pi 5. Can you even buy them yet? I know there's been all of this hubbub about them. Oh, and they're expensive and out of stock. So on Pi Australia, Raspberry Pi 5, $100 and out of stock. Now, what could we do with PCIe? Ah, and CM4 also has PCIe. Oh, Gavin asked, how about option for Ethernet over power? Is that a more secure option? That is an interesting idea. I've never even thought about that. I don't know that it's necessarily any more secure, and I would think that it's probably fairly slow. Also, it means that we have to deal with the power side of things. So normally that is done, something like Ethernet over power is done when you have mains power somewhere and you want to be able to pass network over that mains power. Like from, say you've got an access point or something near a power point, you plug a device into the power point, which is like your Ethernet, one end of your Ethernet, and then at another power point somewhere else in the house you plug in another device which gives you power coming out and also Ethernet, and it passes the Ethernet over the mains wiring in the house. But I don't think that's a great solution for this. It's an interesting thing to play with in situations where you need to get Ethernet through, you've already got mains wiring and you can't do anything else. But I think that's a very narrow specific use case, and I don't think it will help in our situation. So what's more, excuse me, what's much more interesting is the power over Ethernet, not Ethernet over power. Right, so Austin says all that would be needed for CM4 is an Ethernet jack and PoE, and the UFL antenna to the CM4 board, and probably USB as well. Yeah. Wagon Load said USB to Ethernet adapter. Yeah. Yeah, I think the CM4 is probably, I'm pretty sure that that's where we ended up. As we're going through options. Let's go back to these notes, because I will look up all the CM4 info, but I just want to have a quick squiz through these notes to see if there's anything else that sparks memory. So reading the GPIO, that's how to do it. This is the option for the Ethernet jack. This is info from Tony S about the overlay, external antenna mod for the Pi 02, doing the W5500, yep, temperature sensor, okay, oh that's right, yeah, I did actually have that working at some point. I think this validation list here, I think this is just the tests that we did on the stream, and I think the temperature sensor I did actually have working at one point. What else is there? WS2812, so that's driving the LEDs. And now we're getting back into old historical stuff. So this was Armbian running on a Radsha RockPi S. Armbian, Ubuntu. Yeah, these were older and older versions of messing around. All right, so let's get back to the CM4. Let's see what options we've got. 652 products, 652 Raspberry Pi things. Okay, computers, Raspberry Pi 4, Raspberry Pi boards. Where is CM in here? I know, I could just do a search for CM. I'm being silly. In fact, let's do that. Let's go do a search for CM4. Sold out, sold out. Okay, let's try at Core Electronics. Back to here. Oh, come on. Raspberry Pi. Is there a CM listed as in stock here? Okay, I will just search. CM4. $100 and it's out of stock. Oh, this one is 2 gig of RAM, wireless, 8 gig eMMC, out of stock, out of stock. Yeah, not looking good. Out of stock. Where's isn't there a site called Pi Finder or something? Raspberry Pi Finder. Like there's a stock location site. Pi Locator, that's the one. What I want to find is CM4. CM4? Order status, vendor, Pi shop. Now, can I filter this down to, yeah, get rid of that. Search history, vendors, regions. Okay, Australia. What can I get in Australia? CM4, Pi Australia, in stock. Yes. Which is the cheapest one? This one. I thought this was out of stock. Ah, maybe it is actually in stock. Just in that particular variant. There are no longer limits except for how many we have in stock. Okay. So 73. Oh, hang on. Raspberry Pi 4 Model B. No, I wanted the CM4. Why did that take me to, oh, okay. It's because that's what it is, Pi 4 Model B. But I want a CM4. Oh, okay, no, it just doesn't have it. Pi Locator, yes. So perhaps buying a compute module is still a problem. Let's get rid of Australian region so I can buy from anywhere, and I want to filter for CM4 stock. Okay, so it's listing all of the in-stock ones first. Oh, DigiKey. Interesting. So DigiKey have 8 gig 2 gig RAM, 8 gig MMC with Wi-Fi for $45 US. Well, this is okay if there is actually stock. Okay, show it to me in Australian buckaroos. 466 in stock, $73. Okay, so this is a viable option after all. It looks like I can actually buy them, which is a very nice change. Yes. So Tradie says, hardware is well and good, but without software, you're up shit creek without a paddle. That's true. Now, the thing is that I've already had this working on a Raspberry Pi. In fact, that Pi, this one here, with this hat on it, so this is my PoE hat. I'll stick this back on. This has actually been successfully running as an access point. There we go. This SD card has on it a version of Raspbian with with all of the AP stuff, including personal pre-shared keys working. It is fully working. Like, that is an actual working access point. It's making the form factor nicer is the challenge now, putting it inside that little box. So something like this module, the CM4, should run the software all fine. It's no problem at all. And I think I might have even ordered some of the connectors. So these things have a, that's the compute module on a carrier board. It's got the header underneath, which brings out all of the useful stuff. Okay, I am very tempted to go down the path of doing something like a CM4. Now, because they're expensive. I'm just going to add this to my cart so that it's in the cart for next time I'm messing around on DigiKey. Yeah, at that price, like $73, it's not the price where I would just go, oh, I'll stick a few of those in my cart and order it. It's I'll probably order one next time I place an order with DigiKey, I will include one in the order because yeah, the cost adds up rapidly if you start adding more of them. And if I need to see if this will work at all first before I actually end up buying however many I need. Oh, Simon says Element 14 also have stock of the CM4. Yeah, Tradie says, worst part I hate about every new single board computer, the software sucks. Yeah, it's not, I don't really have that problem on the Raspberry Pi series because Raspbian is reasonably decent and if limited, and you can run Ubuntu and Debian on them, which is good. It gives you full access to everything you could ever want. Oh, Ray, you're heading off. Well, thanks for coming along. Yeah, Trev says it's a messenger system, not just a router. Yes. Yeah, we can run whatever we like on a Pi. So it can be the MQTT broker, it can be a router if necessary, it can be a DHCP server. You can do lots of stuff. All right, so what this means is, now I have a vague recollection that I may even have like a library part for a CM4. Let's just open this and go to add part, and let's see what I've got. Superhouse MCUs, would it be in MCUs or in modules? Oh, there's an RP2040 in there. What am I looking for? No, it doesn't look like I have a Pi 0. What about in modules? Ooh, here we go. Oh no, it's a Pi 0. No, what I'm looking for is a compute module. I have the Pi 0 in here. That's probably what I was thinking of. No, I don't have a compute module in here. All right. So that's okay. This is at this stage. This is all just figuring out what we're going to do. Now, Wagon Load said, can an ESP32 be used as an access point? Yes, it can, but it's limited. That has been considered, that was considered fairly early on. Oh, Wagon Load says, I have a CM4 footprint for KiCad. Cool. Well, what I should do is use KiCad for this project. So if this is all going to be redesigned and it's not going to be done with the, like, if it's a radical redesign, maybe the general form factor will stay the same because we want to keep the enclosure mounting and everything. But if everything else in here changes, and if we're going to drop the W5500 and make various other changes, like maybe implement Austin's auto detection circuit for PoE, that would be the place where it would be sensible to switch this project to KiCad. This is probably as good a project as any for me to start messing around with KiCad and getting up to speed with it. Oh yeah, Austin pointed out a couple of limitations with the ESP32. Sorry, I was on that train of thought and then I totally lost it. Austin said maximum 8 items for ESP32 AP. Yep, so you can only have 8 other devices connected. And ESP32 won't let you do pre-shared keys. Yes, because there is not the software support for all of that. Celtic Beast. Morning all, what did I miss? Has John stopped waffling? Never. There is 0 chance that I will stop waffling. I am just waffling at this point. Oh, okay. So Austin just put in a link. I don't know what it is, but I'm going to click on it because it's probably relevant. Okay, here we go. Raspberry Pi compute module for Eagle footprint. Yeah, this is for Eagle. Oh, cool. Thank you. But what you should not be doing, Austin, is encouraging me to stay with Eagle or Fusion. But yeah, you're right. I could grab this footprint and seeing this reminds me. So we've got these 2 connectors here that go on the PCB. I am pretty sure that I bought some of those ages ago, because like a year ago when we were looking at this project and talking about compute modules. The thing is that there is the CM4, but that is not the only equivalent, because Raspberry Pi Foundation came out with the CM series. There was the CM3 before it, which was in a, and they had the other form factor, which was the one that went into like a memory. It was like a sodium type form factor before they switched to this form factor with the 2 connectors and the board that plugs straight into it. Other companies made equivalent boards in matching form factors. So I think there are a number of other options, not just the Raspberry Pi. There is also like a Rock Pi equivalent in this form factor and a bunch of others. Stephen said the cows would have come home and gone back out again before John stops. Yeah. Oh, Scott says, just stick a low-end Intel CPU and RAM on board and build from there. I don't have that sort of skill. I think you're mistaking me for someone who knows what they're doing. Austin says, RockPi has a CM3 design. Johan says, then I could run OpenWRT on it. Yep, that would be an option too. All right, so Austin, stop giving me reasons for sticking with Eagle. I mean, this would be very useful anyway. So, where was I? Oh yeah, I was back in here. Okay, so let's bring up, where is it? I'm going to bring up notes. Which of my notes? Oh, there's a README as well. What does the README say? I think that'll just be an overview. Yeah, it doesn't have anything very useful in it. I want notes. Is that the right one? No, it's the Notes 2 document. All right. Let's do some... Let's start recording some things. Otherwise, next time I look at this, I'm going to have no idea. All right, validation. Adding more stuff to the top. 2023-10, what date is it today? I believe it is the 8th. Design rethink. Switch to CM4 is the question. Hang on. Maybe that's a little bit better. No, it's not. I still lost my voice. What is going on with my voice? I don't know. Okay, hang on. I've got to mute myself again for a second. Okay, maybe now I feel a little bit better. I sound a little bit better. Yeah, buffer. Oh, buffering. That's not good. Okay, Aaron said, here are some CM4 alternatives from Jeff Geeling. Awesome. Let's stick that in here. So this was from December 2021. That's ages ago. Okay, but still very useful information. Alternatives, I'll stick that in there. So Pine 64 and yeah, so the Raja version of the thing is the one that I was looking at, and I'm pretty sure that was available. Yeah, my preference is to go for the Raspberry. I was going to say the word genuine. The Raspberry Pi Foundation board for universal availability, I suppose, and consistency. The thing is that, yeah, sometimes you often can't buy them, but at least when you do get them, you know what they are. And I don't say that in a way of casting aspersions on Pine 64 or Raja. It's just, yeah, I don't know. I don't know what I'm trying to say. But there are things like this. So this little comment here from Jeff saying that they are advertised as drop-in replacements, but they're not, because there are some pin differences. And yeah, maybe we could work around that. Like we could figure out which pins are equivalent on the different boards, but also the processors have different architectures. Like the, I think Raja's chip is based on the Rock chip CPU, and it's different. So you can't just run the exact same code. Well, the same code, different platform, which means it's got to be compiled for that target, which means the release of the operating system is on a different schedule, etc. There are other issues. So as long as it's available, I would prefer to stick to a genuine, I'll use that word, Rock Pi S. Half an hour? Half an hour.
System notification. 30 minutes remaining.
Yeah, so people are saying that there is buffering, but I'm not seeing that problem anywhere in the YouTube console. Normally it complains. It says insufficient data or something. Okay. Oh, Luminator said, DigiKey has a great page for creating a Raspberry Pi compute module for CM4 carrier board in KiCad. Oh, awesome. I am... Luminator, I'm pretty sure you're a mod, so you can post that if you like. How to make a Raspberry Pi? DigiKey. All right, I'm not going to actually play this because I'd get copyright infringed. Part 1, DigiKey. Who did this presentation? I don't know. Anyway, I will I will look at that later. But that link is in the chat. Illuminator put that in if anybody wants to check it out. Now, this... Okay, so... I promise, after months of testing dozens of PCI Express devices with the CM4, I've encountered issues with some drivers, notably GPU graphics cards, some storage controllers, and the Coral TPU. Okay, but what about Ethernet? How do we attach Ethernet onto a CM4? I bet there are a bunch of people who have already done projects that do exactly that. So the logical place here is to look for something like CM4 Ethernet. How about something as basic as that? Datasheet, getting started with a dual gigabit Ethernet carrier board. Oh, from Seed, mini dual gigabit baseboard. Right, dual gigabit Ethernet. I don't need gigabit Ethernet. Even 100 megabit Ethernet would be fine for this particular project. Gigabit would be nice. And these are all dual. But I don't need dual. But let's check out what Seed have done with this, because what we could do is probably crib from their design. Now, the ideal thing would be to find a project that someone has done that has PoE support as well. So what have we got on here? Dual gigabit Ethernet for soft router stuff, external fan, blah, 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 blah. USB 3.0 to GBE. Okay, so they're using a gigabit Ethernet bridge. They're using a microchip LAN 7800. Okay, that's interesting. Camera, display, FPC, external fan power. So there's no PoE on this, but I'm pretty sure we could add that. That wouldn't be a hassle. Due to the high level integration, must be used with a CM4 heatsink, otherwise it may cause USB or Ethernet instability. Okay, so that's something to keep in mind. SD card slot, and here we have part of the schematic. All right, well that's a good point. All right, before I forget about this, before I totally get into looking at that, I'm going to stick that into my notes. Seed dual, no, not speed, don't autocorrect that. Seed, stay there, that's right. CM4 dual gigabit Ethernet board. So now we can find that again in future. Amanda said CM4 has a built-in Ethernet controller. Why didn't the say speak that either? Oh, maybe you're not a mod. Okay, I'm not quite sure how to resolve that right at this point in time. So I'm just going to go back to this. Now, Austin said data sheets, blah, page 11. Here we go. And page 11. Page 11, that's 7, 10, 11. Alrighty. Get some zoomage. Looks like that was done in KiCad. So, CM4 GPIO. Alright, Ethernet. So we've got Ethernet over here. What do we have? Mag jack. So is this module 4? Oh, it's the I/O board. I see, I see. At first I thought that what we were looking at here was the schematic for the CM4, but it's not. This is the schematic for the I/O board, which is a carrier board that the CM4 plugs into, which gives it Ethernet capability. Yeah, so this is a great reference design to be working from. Raspberry Pi treating. Ethernet, what else have we got here? PCIe X1 controller. So there's a whole bunch of power supply stuff there. Is there any more? Okay, so USB hub, current limit switch. All right, but what I'm interested in is this part that Austin linked to back here. So Ethernet, let's figure this back out. So this is the Ethernet connector. You can see it's got the status LED connections down here, shield. Then we've got these taps. So these are coming, these TR is transformer tap, and there's transformer 0, 1, 2, 3, and they are coming up off these center taps on these transformers. So these transformers are magnetic, so inside the connector. And then we've got transmit data 0 positive, transmit data 0 negative, transmit data 1 positive, transmit data 1 negative. And the same for these 2 and 3. So we've got the 4 pairs of Ethernet coming in here. All 4 pairs are required for gigabit, and then we've got the stuff being tapped out there. Now, what have we got? TOD, CT. That's the center tap connection. Yeah. So this connector I don't think would be suitable for PoE, but that doesn't matter. Oh, Wagon Load says, can you post a link to that page? Right, so this is the data sheet. Austin did link to it, but I will drop that link back in again. Luminator said the CM4IO board reference design is available too. You can start with that and subtract components you don't need. Yes, that is... oh, okay, so it's available like as an actual KiCad project. That would be a cool way to begin. Just start with the literal KiCad files and delete a bunch of things and change the form factor, etc., and add PoE and change over the connector to make it PoE compatible. So yeah, at least that way we would end up with things like the I/O headers and everything that we need. Yeah, that's a good idea. So I should see if I can find that. Austin says, and those Ethernet pins go direct to the connector left of the page. Oh, Johnny, you're heading off. Good 2:30 after midnight, ladies and gentlemen. Yeah, that's a late one. Thanks for hanging around this late, Johnny. Go and get some rest. Sleep well. Okay, so yeah, so we've got these connections coming off here. So we've got all of the oh, okay, I was saying transmit, but it's I don't think it actually is. TR in this sense doesn't stand for transmit. All right, coming back across, 40-way GPIO header. Yeah, so, and then there's the compute module 4. So this 40-way GPIO header, this is the equivalent of the header that would be on a full-size Raspberry Pi. It's just that the compute module doesn't have that header, obviously, because the whole thing is small. It's just a little surface mount module. So this breaks out what would be the equivalent I/O so that you can use the compute module for in the same way you would use a full-size Pi. So that's not useful to us. But over here we have the footprint for the compute module 4. This is what the CM4 plugs into on this I/O board, and brings out all of the I/O. All right, so let's have a look. Here we go, Ethernet pair. How this couldn't be much simpler. This is really cool. Yeah, thanks, Austin. So what we have here is Ethernet pair 1 positive, Ethernet pair 1 negative, and they are going to TR-D1P and TR-D1N. So these connections on the compute module 4 are the Ethernet controller just linking straight across to the mag jack. That is ridiculously simple. I think even I could manage that. Be a bit of a stretch, but I think I can manage it. Drop 2 things on a board and route some tracks between them, and add some SD protection, as someone pointed out. Oh, Johnny says, oh, I have a new red icon. I don't know what that means. I think it's related to membership, maybe, like channel membership. David Crisp said challenge accepted. Yeah, I think this challenge is accepted. Okay, so recapping. I would like to go for a Raspberry Pi board of some kind, largely for the very broad support for it. Now, something like an equivalent SBC, like one of the Raja boards, they may technically be just as good in terms of what they have on them. But because the user base is smaller, they don't have as broad a software support, and they don't have things like the same level of forums and discussions and third-party things that are supporting it. So I would like to, so I'm inclined to go for a Raspberry Pi Foundation board, just for that sort of general broad compatibility. And using the CM4 is good because what it allows us to do is not be constrained by the mechanical structure of a Raspberry Pi with its connectors and everything in places that are not necessarily where we want them to be. So I think the CM4 is the way to go, and it also gives us gigabit Ethernet, which, as I've said, is overkill for the situation. Even 100 megabit Ethernet would be good enough. But if we can do a gigabit Ethernet and do PoE in a reasonably simple way and support like full standards compliant PoE and DIY PoE if you just want to send 12 volts down the wire or whatever, then I think we would be in a really good place. So then the question is, this is the other unresolved thing, is the antenna for Wi-Fi. Because of course the whole point of this is to make a wireless access point. Sion! Doesn't matter if you're late, you're here, and that's all that matters. Yeah, okay, so Johnny said, watch Maya Make's last video on element 14 for more details on soldering a header for the CM4. Yeah, and Stephen says, the hardest part about the CM4 is making sure your connectors are exactly right, as they don't have much tolerance and they are a 0.2 millimeter pitch. 0.2 millimeter. That is crazy. Yeah. Ah, Austin says it has the UFL connector on the CM4. Awesome. That is really nice. Okay, let's go back to CM4. I want to see a picture. Not that one. I'm going to leave that one open for future reference. Actually, did I put this into the... I'm going to add this into the document anyway, just to make sure it's not Eagle footprint for CM4. Just to make sure that I can find it again if I want to. Now, where is the CM4? It's rock chip. All right, CM4. And is the UFL connector on the top? Yes, it is. It's right there. That is very nice. What have we got? 15 minutes remaining.
System notification. 15 minutes remaining.
Which means it's getting close to barbecue time. Now, okay, so the CM4, what we're looking at here is the top of the CM4, and the connectors are on the bottom. So this plugs into the carrier board exactly like this. And then you can see that there is the UFL connector on the top here, all exposed nicely where we want it, which is perfect. Okay, the more I look at this, the more I think, yes, CM4 is the way to go. I don't think it makes much sense to go for another option. What was mostly scaring me away from the CM4 in the past, there were two things. One is the unknown of how to connect Ethernet to it. But now that I've seen how easy it is, yeah, that is that fear is gone. And the other, now where was that thing? Here. Yeah, so the connections through here of getting Ethernet onto this That is so easy that that's not a problem. The other, as was just mentioned in the chat, is the issue of how to put the footprints down accurately for the, well, not the footprint so much, it's the assembly. Getting the assembly to work and have those connectors aligned so that you can plug it in, because 0.2 millimeter pitch connectors are very, very finicky. You've got to make sure that they are in exactly the right place, and when they reflow they sit just right. They don't get pulled sideways by surface tension or anything else. Kodiak. G'day Kodiak. Said, make sure the onboard Wi-Fi supports AP mode. Yeah, is there any difference between the silicon on the CM4 and on the full-size Raspberry Pi? I have a feeling that they're running the actual same chipset, and it'll be the same Wi-Fi. Now, I know that it works on the full-size Pi, so my assumption, and assumptions are never good, is that it will also work on the compute module. Now, as far as I know, anything that works on a full-size Pi will also work on a compute module. It just doesn't have all of the connectors and stuff. So that's a very valid point to bring that up. I was making an assumption. Oh, Johnny! Very generous.
Has gifted 5 memberships.
Thank you, Johnny, for donating those memberships. That's really cool.
Aaron Knox has received a gifted membership from Johnny Bergdahl.
Yeah, Amanda said the CM4 is the full Pi 4 with everything opened up. Yeah. So I think we're good. It's definitely, it is a good question to ask, because I was just going on the assumption that it works on a Pi, therefore it will work on a CM4, which may not have been the case, but hopefully it is. So yeah, those two things. It is the, it was Ethernet, which I think is fine. All right, so let's have a look at the, where is this? Compute module 4, I/O board. If anybody else has found it already, where is the KiCad project for the Raspberry Pi CM4 I/O board KiCad? I'm just assuming that it was done in KiCad because it looks like KiCad. CM4 KiCad library, no, customized CM4 I/O. Oh, what's this one? Compute module for I/O board. Released it. Oh, they also released the board schematics and yes, okay, product pages here, documents. Here we go, KiCad files. This is exactly what we want. Wagon Loads said, is there a CM4 connector holding jig to keep everything in place when soldering the connectors? Yeah, that's a good question. What happened then? Did I just download it? I don't know. I clicked on this and then I stopped paying attention. Is it in my downloads? Let's have a look. Downloads. Is there a date added? No, there is not. Okay. KiCad files. What happens if I click this? Downloads? Come on. It has not appeared in my downloads directory, even though I clicked it and something happened. Weird. Okay. KiCad, blah, 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 blah. All right, let's go back to here. I think it was Johnny. Someone pointed out that it was, no, David said second one in your search. Second one. That was the buy link. No, this is the CM4 library and footprints. What I'm looking for is the I/O. Raspberry Pi baseboard. KiCad forum. Let's see if this has a link to it. Compute module I/O board. Rephrased. Okay, compute module. That's a link. All right. Maybe it's just linked from this page. From the. Here we go. KiCad files. Let's see if this link works. Aha, I just saw it download something and it just appeared in my downloads folder. Nice. All right, let's go to Superhouse projects. I'm going to add these files into here, hardware. Sorry, you can't see what I'm doing right now, but all I'm doing is grabbing the download and extracting it into the project directory, and then I'm going to bring it up on screen. Here we go. So let's see, what have we got? GPIO, high speed, where is CM4 v5.project, and a whole lot of other supporting stuff. Looks like they provided lots of things in there. Let's see if my KiCad is up to date enough to be able to open it. PCB. It keeps dropping down on my other monitor, so I've got to move it up. Alright, so this is the KiCad project for the I/O carrier board. Now, what am I looking at? Oh, file was created by an older version of KiCad. Well, that's alright. Looks like I am up to date enough, at least. So I'm running, what am I running at the moment? KiCad 7 something. Where are we? KiCad, about KiCad. I'm running 706 release build. Yeah, I want to... So this build is a little bit old. I want to grab the new one that's got the multi-pin functions built in. That's really, really cool. So you can do things like, in the schematic view, pull out... come on, here we go. Update PCB? No, I'm just going to... Sorry, KiCad just came up with a warning. I was just puzzling over what it was. Alright, so doing things like, say if we go into the connector, and, oh, interesting, HDMI, yeah, I don't need any of that stuff. Yeah, there is a really funky thing in the newest KiCad build where you can do things like multi-select pins, and then there's a new menu option in here which doesn't exist in this build of KiCad. There's like a multi-pin thing that then drops out a sub-menu, and you can do things like route, you can then bring nets out of a whole lot of pins simultaneously, or do like apply bulk actions to pins. And when you're doing doing breakouts from parts or from connectors or ICs or whatever, that's really useful. So yeah, there's some cool stuff in the latest nightlies from KiCad. Where's the fit? Zoom to fit, there it is. Okay, so back to the PCB just temporarily. So what have we got here? This one has those connectors. I don't even know what those are for. What have we got down here? A couple of, oh, these are the USB? Yeah, 2 USB connectors, and down here we've got, there's an Ethernet connector. It's jumping around. I need to get my
system notification.
Zoom and pan. Well, you can see all the match length traces on here. I need to get my zoom and pan sorted out in KiCad. Then what's over here? Another connector of some kind. What is that connector? I don't know. HD, HD1, HD VBus, MT4. I don't know what that is. Is that USB? Oh, there's USB OTG header over here. But this header is weird. I don't even know what that is. Okay, and there is the CM4 footprint up here with the 2 surface mount connectors with the ridiculously fine pitch on them. Look at this, 0.2mm pitch headers. That is going to be such a pain to assemble. And there are 2 of them, and they have to be spaced relative to each other in exactly the right location because the board plugs into both of them at the same time. Yeah, that's not going to be fun. My guess is just there's going to be power supply up here, just based on all of this thermal wires, like all of this stitching that's through here. That's got to be power supply. Yeah, but at least it gives us something as a starting point. Ooh, I'm just experimenting with zooming here too. No, I need to be able to zoom and pan quickly and easily. So just getting a feel for how KiCad does it. So if I wanted to zoom in on a particular thing, it's being very jerky, but I think that's just my computer. Yeah, I need to get the feel for how KiCad does this sort of thing so I can be fast and efficient at it. One thing that I really want is horizontal panning, like being able to just grab the board and move it around. There's a key binding for that, I think. That click. Okay, I am happy now. On my trackball.
Underscore creation set Alt+3.
Yeah, Alt3. Okay, I'm going to try that Alt3. Hang on. Oh, Alt3 just went to 3D viewer. Here we go. It's just opened on the other monitor again. Okay, I wonder if this works with the space mouse. That would be really cool. It doesn't seem to be. Is my space mouse working? No. Sadly, it looks like the space mouse doesn't work on it. Yeah, so 3D view, let's do a zoom in. Anyway, back to the other exciting thing. Where are we? This discovery. Okay, this discovery. I know this sounds stupid. It's just such a little annoying thing, but this makes me much happier about KiCad. What I'm used to being able to do in Eagle is 2-finger drag to move the canvas anywhere that I want. And I don't want to zoom in and out. Like, I don't want to zoom out and then zoom in on a different location to be able to just move sideways. I want to just move the board around, staying at the same zoom level. And what I can do is right click on the trackball and I can move this. So yeah, it's definitely not as convenient as two-finger click on the trackpad, but it is workable. Because normally I have trackpad under my left hand and trackball under my right hand. And that way I can grab a part with the trackball and then zoom and pan with the trackpad simultaneously. So I'm using both input devices at the same time. But this is kind of acceptable. So, we have studio invaders. So yeah, being able to do this is much better than what I had before. So I thought that I was stuck with zooming out, picking a new location and zooming in on it, and that sucks. At least being able to do this is a lot more comfortable. Yeah, okay. Now, right, so I've got this project now in the, yeah, I still know nothing about KiCad, but let's see if it works here. Yes, it does. I can horizontal pan in the schematic as well. That's very good. Now, one thing, this is HDMI on those two connectors.
System notification. Stream is over.
It's over when I say it's over.
It's been difficult to keep up as you've been on the road.
Yep. So what I want to do is be able to delete stuff. Like, I don't need HDMI. So if I just delete this part and then resync the project, but this is all something to discover another time. I think what this gives me is a good starting point. And I am switching, okay, I'm saying it now, I am switching to KiCad for the remainder of this project. We're going to do the access point in KiCad. Yes, at last the moment has come. So guests have arrived and I saw that Keith is out there as well. He's out probably starting to get the barbecue ready. So,
You didn't want to be part of the invasion.
no. So if you are coming along to the Superhouse barbecue this afternoon, I will see you soon. and I think I've got plenty of food.
Don't rush.
But it's a-
Go over time if you want to do what you want to do.
Said save this part number.
Save as part number, okay.
00177NL.
Okay, I am going to take that part number and stick it in the
Creations said save this part number
document.
00177NL.
Austin's part number. I don't even know what that's for, but I'm just saving it.
That thing just sounds like a nag.
Yes. All right. I don't know what that part number is for. I'll work that out next time. But I'm going to wrap up because I do need to actually be like present for people here, not just on the stream. And I needed that part number too. Yeah. I still don't know what that part number is for. Oh, readily available Ethernet jack. Oh, cool. Okay. That's great. Thanks, Austin. Now, one of the issues is the Ethernet jack has to be one that has the tab on the correct side. So I'm going to look that part up. I won't do it right now. Oh, with 1 gig. Oh, and correct clip orientation. Austin, you're my hero. You've solved those problems already. Okay. I think we didn't actually make much progress today on this project, but at least now we've got some orientation on where we left it a year ago and what needs to be done next. So maybe next stream I will be actually doing stuff in KiCad, making a fool of myself because I don't have a clue what I'm doing, and we can do version 3 of this access point with a CM4, which I need to order as well. So thank you very much for everybody's input on this and ideas, and the result will be much better than if I just figured it out on my own. I am going to go, and I will see some of you really soon in person right here. We're going to get the barbecue going, and I will see the rest of you next week. Sunglasses go on. It's barbecue time. Come down, grab a sausage, watch some Bathurst, and I will see you all next week. Thank you very much. Everybody wave.
Bye.
Bye.